Yeah, so you know how museums have all these old things, like bones and rocks and stuff? People often think everything important has already been found. They figure if a fossil is in a museum, someone has looked at it really carefully. They think scientists have figured out what it is, and maybe they think it's all cataloged and put on display, or at least easy to find. But that's actually not always true. Not even close, really. There are definitely still undiscovered fossils sitting in museum drawers, on boxes, in back rooms, just waiting. It sounds a bit wild, right? How could something be in a museum but still be undiscovered? But it happens a lot more than you'd think. And it's for a whole bunch of reasons. One big reason is just the sheer amount of stuff. Museums have so much material. Think about a big natural history museum. They don't just have what you see in the public halls. That's a tiny fraction. Most of their collection is stored away, it's in special rooms. These rooms go on and on. They are filled floor to ceiling with cabinets. These cabinets have drawers. And these drawers are packed. There are thousands, hundreds of thousands, sometimes millions of specimens. Each one might be a rock, or a shell, or a bone, or a whole skeleton. And imagine all the fossils that have been collected over hundreds of years. People have been digging up fossils for a long time. They brought them back to museums. Many of these early collectors were just trying to get as much as they could. They might not have had the time or the tools to clean every single piece perfectly, or to study every bit of rock they found. So a lot of specimens came into museums looking like just ordinary rocks. Or just pieces of dirt. Maybe they had a small bone sticking out, or maybe they had nothing visible at all. They got labeled with a general location and a date. Then they went into a drawer. And sometimes they just stayed there for decades, even for over 100 years. Another reason is about what scientists knew back then. Science changes. What was important 100 years ago might not be what's important today. And what we know about evolution changes. Old theories get updated, new ideas come along. So, an early paleontologist might have been looking for big dinosaurs, or maybe they were really focused on a certain kind of ancient fish. If they found something that wasn't that, they might have just put it aside. Maybe they thought it was just a common bone, or maybe they thought it was too small to matter, or too broken. But now, with new techniques, we can look at those unimportant pieces again. We can use different ways to see inside rocks. We have better microscopes, we have CT scanners. These machines can see things hidden inside a rock, things that no one could see before. And sometimes, what was thought to be a common bone turns out to be something really rare. Maybe it's a completely new species, or maybe it's a missing link in an evolutionary story. It happens. Think about how a fossil gets found in the first place. Someone is out in the field. They find a rock that looks interesting. It might be a small piece. They bring it back to the museum. Then someone has to prepare it. That means carefully chipping away the rock around the fossil. This is called the matrix. It's slow work. It takes a lot of skill. And sometimes there just isn't enough time or enough people to prepare everything. So, a lot of specimens are still in their original rock. They are in matrix. You can't see the fossil clearly. You might just see a tiny edge of it, or maybe you see nothing at all on the outside. But inside that rock, there could be a whole skeleton or a really important bone. It's like getting a present, but it's still in the wrapping paper, and nobody has opened it yet. Or maybe they opened one corner, saw a bit of ribbon, and put it back down because they were busy. And it's not just big museums, smaller local museums can have these treasures too. Sometimes a local person finds something cool, they donate it to their town museum. The museum doesn't have a lot of paleontologists. They might not have the money for fancy scanning equipment. So it goes into storage, and maybe it stays there for a very long time. A famous example of this kind of discovery is the Archaeopteryx feather. Archaeopteryx is a really important fossil. It's one of the earliest known birds. It shows traits of both dinosaurs and birds. It's a key part of understanding how birds evolved from dinosaurs. And it helps us see the transition. In 1861, a single feather was found in a quarry in Germany. This was near where the first full Archaeopteryx skeleton would later be found. The feather was clearly bird-like, but it was found in rocks that were very old. Rocks from a time when birds were thought to not really exist yet. This feather was a big deal. But later, in the 1970s, a scientist named Peter Wellnhofer was looking at the original Archaeopteryx skeleton. It was in a museum in London. He noticed something small. There was a faint outline on the rock slab. It was a single feather. It was a primary feather, like a flight feather. It was on the wing of the Archaeopteryx skeleton. This feather had been there all along. For over 100 years, nobody had really seen it or noticed its significance before. It was just part of the rock, but when Wemhofer looked closely, with fresh eyes and a better understanding of what to look for, he saw it. This wasn't a separate feather, it was part of the animal. It confirmed the bird-like nature of the creature even more directly. And that's a good lesson. It's not always about finding totally new things. Sometimes it's about seeing old things in a new way, with a different perspective. Another thing that happens is misidentification. Someone finds a bone. They think it's from an animal they already know about. Maybe a common reptile, so they label it that way. And into the drawer it goes, but years later, another scientist is working on a specific group of animals. Maybe they're looking at the evolution of early mammals, or a specific lineage of dinosaurs. They pull out those old specimens, they look at them very closely, and they realize, wait a minute, this isn't what they thought it was. Sometimes that common reptile bone turns out to be from an early mammal, or from a creature that's a blend of reptile and mammal features. These transitional fossils are super important for understanding evolution. They show how one group of animals slowly changed into another, and finding them hidden in plain sight, misidentified, is a big deal. It reshapes parts of our evolutionary tree. It's like a detective story, really. A cold case. The clues have been there all along, but no one had the right knowledge, or the right tools, or the right question to ask until someone new comes along. And sometimes it's not even a case of misidentification, but rather a simple lack of understanding or specialized knowledge at the time. Paleontology is a huge field. You have people who specialize in dinosaurs, others in ancient plants, others in tiny marine creatures. Someone working on big bones might not recognize a small, fragile plant fossil hidden in the same rock, or vice versa. So a huge slab of rock might come into a museum because it has a nice big dinosaur bone. But embedded in that same rock, almost unseen, could be microscopic pollen grains, or tiny insect wings, or small shells that tell a completely different story about the environment. These tiny things might have been totally ignored for decades, because the focus was on the main event. But those tiny things are crucial for understanding the whole picture. They tell us about the climate back then. It's what other life was around, how the whole ecosystem worked, and how that ecosystem changed over time, influencing evolution. The growth of digitization projects also helps here. Museums are starting to photograph their collections. They make them available online. This is a huge job. It takes forever. But it means that a scientist in Japan can look at a fossil in a London museum without ever leaving their desk. And when thousands of people can look at these images, the chances of someone spotting something new go up. It's like crowdsourcing discovery. Someone might have a very specific expertise. They might spot a tiny detail in a photograph that an in-house curator missed. This new detail can point to a new species, or a new understanding of an existing one. Think about the importance of these discoveries for understanding evolution. Every fossil is a piece of a puzzle. It's a snapshot of life in the past. When you find a new one, especially one that fills a gap, it can totally change our understanding. For example, maybe we have a very old animal, and then a much younger animal. We know they are related, but there's a big jump. We don't see how the changes happened. This is called a gap in the fossil record. And then someone opens an old drawer. They look at a fossil that was just labeled "unidentified bone." They clean it up. They study it. And boom, it's exactly the animal that fills that gap. It shows the transitional features. It shows how the older animal slowly evolved into the younger one. That's a massive discovery. It helps us see the slow step-by-step process of evolution in action. Sometimes these hidden gems are not even fossils of bones. They can be trace fossils. These are things like footprints, burrows, or even fossilized droppings, coprolites. These traces tell us about the behavior of ancient animals, how they moved, what they ate, how they lived. A museum might have a slab of rock because it has a nice plant fossil. But years later, someone might notice faint ripple marks on the surface of the rock, or a series of small depressions. These might be overlooked by someone focused on the plant, but to a trace fossil expert, those marks could be ancient footprints of an animal. It's a very early one, telling us something new about how animals started moving on land, or how they interacted with their environment. These kinds of discoveries add another layer to our understanding of evolutionary pressures and adaptations. The process of finding these hidden fossils is a real testament to how science works. It's not always about grand expeditions to remote places. Sometimes it's about slow, careful work in a dusty room. It's about looking again. And again, it's about asking new questions of old data. And it takes a lot of different people. It takes the people who manage the collections. the ones who keep track of everything. It takes the preparators who carefully clean the rocks. It takes the researchers who have the knowledge to identify what they're looking at. And it takes students who often bring fresh eyes and new ideas to old problems. New technology plays a huge role here. Think about CT scanning. It's like an X-ray, but it takes many images from different angles. Then a computer puts them together. It creates a 3D image of what's inside the rock, without even touching the rock. This means you can scan a whole drawer full of unimportant rocks. You can see inside them. You might find a perfectly preserved tiny skull inside a rock that looked totally plain on the outside. This is a game changer for discovering hidden fossils. It's especially good for very fragile specimens. Ones that might break if you tried to clean them by hand. Researchers are doing this right now. They are scanning old collections, and they are finding incredible things. New species of ancient fish, tiny skulls of early amphibians, whole ecosystems frozen in time inside seemingly blank rocks. Each of these findings can shift our understanding of specific evolutionary pathways. And it's not just about finding completely new things. Sometimes a fossil has been identified, but it was identified incorrectly, or maybe only a part of it was identified. For example, maybe a drawer has a fossil labeled generic ancient lizard, but with a CT scan, someone might find internal structures that show it's actually a very early snake, or a creature that shows a crucial step in the evolution from lizards to snakes. That kind of re-identification is just as important as finding something totally new. It refines the evolutionary tree. The commitment to preserve these collections is also important. Museums are not just places for display. They are huge libraries of natural history. They are archives of life on Earth. Every specimen, even the unidentified ones, has potential. They hold information, maybe information we don't even know how to look for yet. So the ongoing work of curating these collections is vital. It's about making sure these specimens are safe, that they are stored correctly, so that when new technologies come along or new questions arise, the specimens are still there, ready to be examined. And it's not cheap or easy. Collections take up a lot of space. They need specific conditions, not too hot, not too cold, not too humid. They need to be protected from pests. They need people to manage them, to move them, to keep track of them. This is a constant challenge for museums around the world. But the payoff can be huge. Every time a scientist opens a drawer and finds something new, it adds a piece to the puzzle of life's history. It helps us understand where we came from, how life adapted, how different groups of animals and plants are related. It changes our understanding of evolution itself, and it keeps happening. Just in the last few years, there have been stories. A new species of ancient crocodile found in a drawer, a never-before-seen ancient insect discovered in a piece of amber that had been sitting on a shelf, a new early mammal ancestor identified from a tooth found among other reptile fossils. These are not rare events. They are regular occurrences. It shows that science is never really finished. We don't just find all the answers and then stop. We keep looking. We keep asking questions. We keep refining our understanding. And sometimes the answers are right there, under our noses. Just in a dusty old drawer, the specimens in those drawers represent potential. They hold secrets. They are like unopened letters from deep time, and we are slowly learning to read them. Each new discovery, whether from a dig site or a museum shelf, helps us paint a clearer picture of how life has changed over millions of years. It helps us understand the mechanisms of natural selection and adaptation. It's a living testament to the ongoing story of evolution. And it reminds us that even after hundreds of years of collecting, there's still so much to learn. Still so much to discover, not just out in the field under the hot sun, but also right there in the quiet, climate-controlled rooms of a museum. It's a treasure hunt that never truly ends, and the treasures keep revealing themselves, slowly, steadily, one drawer at a time.